I think part of the problem is engineers are used to build and not to solve. We are definitely going in that direction of failing too late and not enough. Engineers are rewarded when they write new code and new feature, when they deliver new value. This is like mostly in a company what happens. But if something fails, it will be invisible. Like it's considered obvious that engineers are supposed to write solid and stable and correct code.
Hello, and welcome to a new episode of Hot Tech. Today, we are with Philippe, and he believes we are failing too late. Philippe, who are you? And can you explain more about why we are failing too late?
Yes, hi Pablo. So my name is Philippe. I've been a web engineer, a Ruby engineer for 15 years or so. I'm also a lecturer at college. I'm also a coach, so I have like many hats, and I'm CTO of Nodalview nowadays. Well, I do believe that we are failing the wrong way in the software industry, and we are typically always failing late, which has a huge cost, and we should learn to fail early at a lighter cost and learn the lessons and have better feedback. I do believe we need to learn how to be better at failing.
Okay, when you say we're failing too late and it has costs, can you develop that a little bit?
Yes, of course. I think many of us software engineers and managers, we believe, we say the sentence, fail early, fail often. This is something we've read. This is something we have said. We just don't do it. But because this is something we say, we kind of understand rationally that failing early means we have a good feedback loop. Also, the cost of fixing a bug while we are writing is basically negligible. This is also why I believe in TDD, right? When we have the failing very, very, very early, it costs almost nothing to fix it. Then the longer we wait, the more it costs, because first of all, we are building upon of failing idea, which means it gets larger, and then it gets deployed, or maybe it starts like having influence on someone else's, like a coworker code. And if we wait even more, it gets deployed, which means maybe our user are starting building that failure, and then we engineers start doing something else, which means the knowledge of what we have written starts decaying. And then 3 months later, it costs more to even remember what we wrote and what was our intention. And then 3 months becomes 6 months, 2 years, and then we have almost forgotten everything. Which means for fixing that failure, we need digging and spending a lot of effort, even trying to understand what our self past, in the best case, what our self past wanted to do. But most often what someone else wanted to do, and that someone else might not remember, might not be in the same company anymore. So for all these reasons, the failure will just cost more and more and more to fix, from almost negligible if we fix something while we write it, to possibly cost like several times more than the actual initial development.
When you're describing it this way, I have a feeling that you're talking more about failing ideas rather than failing code, in the sense that code will tend to fail fast. If I introduce an exception somewhere and it breaks, whereas my idea might take longer to be invalidated or to be considered a failure, right?
Yes, I think I don't know who mentioned it, but I think that there was a categorization of what kind of errors existed. There were 3 categories. The first one are like errors that should not happen. They're pretty frequent. It's like about state of the art, like respecting the state of the art. Those should not happen. They should be fixed immediately. And then they can be prevented. Like good education, good tools should prevent them. They're like complex errors. Those will happen. Maybe what you mentioned about failing IDs. It's about complexity. Like those will happen because there's just no way to automatically prevent them. We can maybe mitigate them, but when they happen, we have something to learn. And then if they happen enough, then the state of the art evolves, and then they maybe become of the first category. And the last category are the stuff we actually experiment very deliberately, like stuff we know are complex and we plan ourselves for failure, but we call that experiment, but it's the same. And those are very intelligent failure. Like we intend to fail because we intend to learn. We don't intend to succeed. So yeah, your question was about failing ideas. I think it's always failing ideas, but there might be different scopes and different kind of consequences. Like if I fail my system design, it's very different than if I fail my like off by one loop.
Yeah, but that's what I meant. That systemically, if you fail your system design, it's something that you almost by design you're not gonna see immediately, right? You're gonna see it once you start actually trying to change the system. Whereas your one off by one error, it might stay hidden for a while, but once it fails, it's quite clear. Okay, I have an off by one error. The system, there is a big gray area where it's like, it's starting to grate me, but is it a failure? But is it not a failure? And so some decisions, I feel like they're difficult to fail fast or difficult not to fail too late.
Yeah, absolutely. So I think it's an oversimplification to talk about failure because there's a nuance here, and it's about like how much friction did I have in my system? How much friction like was the best idea? How much friction can I tolerate? So I think failure is not. It's very rare to be black and white, and we have systems for detecting black and white. So usually we don't have those for a long time. But what the kind of bugs that we have for a long time are that those friction that we didn't see immediately because they were not obvious, but they only appear because there's 1,000 people using our software at the same time, and 10% of them are then like have to wait for an hour or like have incorrect results. Um, so and these are usually complex, like of the second category. So these are difficult to prevent. They could be mitigated, but they will always happen. But I think as engineers, we try to mitigate them a lot more than what they deserve. And I think that the reason for that is multidimensional. One of the reason is that because engineers are rewarded when they write new code and new feature, when they deliver new value. This is like mostly in a company what happens. But if something fails, it will be invisible. Like it's considered obvious that engineers are supposed to write solid and stable and correct code. So this is where the prudence stems for. Like they know that exterior people, like the rest of the company, will always ask them to build more, but it's a given that it has to be stable. So anytime any effort required to fix or improve the stuff, they will have to handle it on their own. They will not be given time. They will not be given any reinforcement, any resource, or much less resources. They will need to fight to get time to fix the stuff. And this is why we are so prudent, because the price it takes, the resource it takes to fix the stuff later, not only will it be more, but it will be paid by engineers like in an invisible way and not rewarded way. While if they take the time when they build a system, they will be rewarded. Like it's okay, this is part of development, and development is seen. It's very visible. Everybody celebrates, development. Uh, Very few people celebrate more stability or fixing the stuff that has been pain in the ass for 6 months. So I think this is why engineers are being prudent and not aiming for failure, because they will have to pay the failure price.
It's surprising because I would have thought that the incentive was the other way, in the sense that I'm rewarded to build quickly. And probably if this breaks, it's not my problem anymore. And so I'm incentivized to not care about the system failing once I'm done with it, right?
I think maybe it depends on the size of the companies, and my own experience has been exclusively with startups and very small teams and small companies, so that there might be a lot of the industry that I don't know about. But from what I have seen, yes, there's a big incentive. There's a small instead than incentive. There's a big pressure for engineers to like release every often as they can, like more frequently. There will never be enough. Like the backlog will never be empty. So there's a huge pressure for that. But engineers know that if they release something unclear and like or unstable, they will have to fix it. So it's like external incentive versus internal fear, and only one of them gets really accepted by the system, like it gets really promoted by the system. I think it's expected for engineers to work like state of the art, to write stable stuff. So it is something they have to own entirely, and this is why I think we are like too cautious. We are trying to prevent big failure because it will not be accepted that we as engineers deliver something experimental.
I see an analogy here in the more feature world, in the sense that not really the technical part of the code, but the releasing new ideas to your customers tends to make them stick, right? Even if I treat something as an experiment, once that experiment is in production, probably that surface area is never disappearing. In my role, it's true that I tend to be really cautious about what we release to the public, because once someone uses it, the pushback from the company not to remove it and not to grade the clients, because hey, you're removing something that X%, it can be 1, 10, 50, doesn't matter, of our clients use. So if you remove it, they will not be happy. And that's preventing a lot of willingness to fail there. Because if I put it there and it's a failure, I still have to maintain it because these 3 clients or these 10 clients or whatever are still using it, right? And so it's still generating pain, although it's not generating new learnings in that area anymore.
Yes, absolutely. And I have like a few very specific example of what you just mentioned in the product that I'm responsible of. Some stuff that we pushed as experiments. Specifically, we had a discussion internally. We're like, okay, here's an idea, and we don't even know if it's technically feasible, performant. Will users actually adopt it? There's so many stuff we don't know, that the only approach is give it a try, but give it a try at like controlled cost. And what happens is exactly the story you told. Like we released something. It's not perfect. It's not really performant. It's not always stable. And there was very little adoption, but there was adoption, of course, but very little. And now we have a very difficult time. So I think it was released 18 months ago. And after 6 months, you're like, there's not enough adoption. Like, can we plan to sunset it? And there's a big opposition to like, no, because there's a few users, they're paying for that. It doesn't cost you nothing to keep it, and that's a lie.
Yeah,
That's a lie. It costs something to keep it. We have to maintain it. There are some specific dependencies for that, and every time we do like full system refactoring, which happens quite a lot, well, that piece is there. And because we did not remove it, even though we mentioned from the start that it was an experiment, now it backfired because it proved that we can't do experiment. So the whole the whole story is really problematic because I take personal responsibility on that. I was like, okay, I wanted to prove that we can do experiments in a different way to actually go for failure, like early failure, and it backfired on me and my team. But so yeah, I definitely agree with you. it's very, very difficult to remove an experiment or just change its scope. And the whole idea of actually failing early and failing often. So the stuff that we say and believe in, but if we want to implement that, we need to have a whole company and structure like system, but human system supporting that.
I'm thinking now it's a different scale because it's Google. I feel like they do what we say we can't do, in the sense that it's Google is infamous for killing products, right? Like they will release something and you can't trust that this thing will be there in 1 year, in 2 years, because they just sunset stuff all the time. But aren't we being quite hypocritical when we criticize that, knowing that in our companies and in our products, we would like to do the same with things that don't have enough adoption, that are treated as an experiment, et cetera, et cetera? Because as users, that if we were using that product, it annoys us quite a bit, right?
Yeah. So I think Google has an innovation lab of some sort. So they at least have guidelines and a structure for those kind of ideas. I don't know Google very good, but I would be curious to talk with the people working in a project in those innovation lab, because maybe they have like at company level, they have a system for innovation. Maybe at team level or project level, what does it feel? Do they have the same? Do they also need to ship features and be prudent? Because maybe it's a product innovation lab, not an engineering innovation lab. I don't know. I'd be super curious to talk with those people. Maybe they have the same pressure as startups do. And you could say the same. You could say like each startup, they have that pressure to deliver. But at like national economy, we do innovation. It's called startups. Like the startups are the innovation lab of the national economy, and then it's just a different scale. But I'm mostly interested in the startup scale. How do we do innovation within like a small company, and how do we change mindsets so that it's comfortable failing? Like how do we apply the right amount of caution, because we trust in the future, we trust that when we fail, the system is going to have our back.
I wonder if even the story you shared was not failing fast enough, in the sense that you set it up as an experiment, right? And it was in your mind quite clear that it was an experiment.
It was a product experiment, yes.
And I understand that it's hard to validate it without clients getting their hands on that. But was there a way to make it fail before it reached the stage of, okay, they are paying for that, so we can't remove it anymore?
So the first question was technical feasibility. So I think we had a few attempts at writing the parts that were the most uncommon and the most unknown, and it could have failed at that part. I mean, we frequently fail at that part because we are doing like edge development. So typically with image generation in AI, there are things that we believe might be done, but we don't know, and it happened so fast that something we failed at 6 months ago are actually doable today. So we do a lot of technical experimentation, and of course, if it fails, it fails. It stops there. But sometimes we manage to find a way for technical feasibility. But the next question is product adoption, and once it's adoption, the next question is product pricing. And it can fail at each of those steps, but because we don't know if there's going to be adoption, that is also like a feedback loop. We don't have a huge appetite at the technical level, initially, because we still don't know if people are going to adopt it. So the initial technical appetite might be, let's spend 5 days building that, or let's spend 10 days building that. And if there is adoption, we'll need 15 more days to actually make it scalable, changeable, like change a few things we did because we aimed for measuring adoption. So we failed. In some sense, we succeeded at making the experiment, but we failed at making something industry grade level. There's also something else is that engineers, we actually love our job or at least part of our job. So we want to write something state of the art. It's uncomfortable. It's unpleasant to write something less good than what we can do. So there's kind of a cognitive dissonance to maybe not do OOP and write like a very long single file, because this is better for an experiment. It's not that we are like doing less than what we can. We are aiming for something different. And if it's an experiment, maybe writing like a single 600 lines of code makes more sense because everything is in the same file. And as an experiment, it's easier to dispose of. But if it's adopted, then we have to refactor it and aim for something different. The success criteria of quality are different, and then we have to refactor it. And then we don't like to to do that. So as engineers, we were like, let's aim immediately for the properly architectured way, right? And there's a bit of a confirmation bias, I think. Also, a bit of Disney thinking. We believe what we wish. There's a confusion between what we wish and what we believe. And this makes things even more complicated, because this is also why we don't fail enough, plus the unpleasantness of failing, obviously.
Yeah, I feel like what you were saying reminds me of something I think Kent Beck writes or has written quite a lot about the value of creating value today versus creating potential value tomorrow, and how you reconcile those two. If you can choose, you should always choose to create value today, but at some point that might block further value creation, right? And so it's what you say of, I have one file that makes 600 lines that works to make value today, but it might block me from creating value tomorrow. And so how do I reconcile those two worlds, and where do I put the cursor there? One thing we're trying at Recover recently is doing a bit of the opposite of what you're saying. What I'm understanding from what you're saying is we try to build the complete feature, but not state of the art, and see if there is adoption. We are now, at least in a few places where we know there is clearly a want from our clients, we're trying the working skeleton approach, where we build good code, but the features are not as complete as they could be. There are missing buttons. There are buttons that click nowhere. There are feedback buttons where we ask, okay, what information would you like here? Stuff like that. But the code underlying that is still quote unquote state of the art, or as state of the art as we can do it. And it allows us to reduce the scope greatly, and to let the clients guide a bit where we can go with this thing, knowing that we have the advantage of, we know there will be adoption for that.
Yeah, but that's a big thing you have. I mean, knowing that there's going to be adoption, it's a little bit like, when someone orders you something, like pay upfront and say, okay, this is the money, and now I want that stuff to happen. So this is something huge to have. But also the way you're describing, I think you mentioned it's incomplete. So it's a good question. Like, incomplete, does it mean it's failing? Well, I don't know. What are the success criteria? I think this is pretty important. This is also why we use MVP and MSP as two very different things. Maybe it's not failing at providing value, so it is an MVP, or maybe more than an MVP, but it's still failing at getting sold, so it's not yet an MSP.
It fails in the sense that it doesn't do everything the ideal version of it would do, but because it is a work in progress, and it's explicitly a work in progress, and we're putting it in the hands of a few clients so they can try it and give us feedback on that, so we actually move in the correct direction. I would say it's failing in the sense of today that's not sellable or usable as it should, but that's on purpose, and the idea is we're gonna keep building on it.
Yeah, but you mentioned like your intention is to write it correctly from the start, like incomplete but correctly, so not failing at design, not failing at code principles, like state of the art code writing. I trust you. I think state of the art, like kind of implicit rules, we do the same, but I would argue with you that you don't know what is success yet until people use it, and what is success even when people start using it, like the actual success will change over time. I do believe that it will change over time. Maybe currently you have like 1,000 users, success looks like this, but when you have 1,000,000 users, success looks like something else. And therefore you can start with beliefs about what is a good system, but you don't have knowledge. So your system might still be failing because you don't yet have adoption, even though you have like a promise of adoption. You don't yet have adoption. And once you have actual adoption, you maybe will realize that a different design would have made more sense. Typical example would be, are you using an event-based system, right? Well, is it state of the art? Yes, but not always.
No, of course.
So if you start initially with like, oh, I'm going to design something for async million concurrent users. So I'm going to have like an event-based system. This is kind of also what some engineers might want. Again, like mixing what is pleasant and what is relevant. So according to what you explained, you might have engineers in your team saying, okay, let's go for an event-based system. It's good design. It's the correct way to approach this. And I would argue that it's not the best approach. Like it is a good approach. Like you cannot really go wrong, but maybe it was unnecessary.
No, sure, and that's why I caveated with as state of the art as we can make it, in the sense that it's a state of the art for what it needs to be today. So basically, it's OP React on the front. Like it's not over engineer. We are not planning for 1,000 users, 2,000 users, 1,000,000 users, because today we don't have that. But we're making the code as changeable as possible once we develop it, right?
But when you do a retrospective, like imagine you do once a month, like or once a week is even better. At the end of the year, like there was 52 retrospectives. How many times can you collect? Oh, we failed at this stuff. If it's frequent, let's say like 52 retrospective, if you have at least, I don't know, 20, 30 times of like someone specifically mentioning we failed at this, we should do it in a different way, I think you're right. But my belief is that most teams I've been working with will have maybe 5, like over 50, like 5 recollection of we failed at that. This is what I mean by we are too prudent. We are too cautious. And because we are cautious, we typically fail less. But then the few times we fail, it happens late at a high cost. And this reinforces the fact that failure costs a lot. So we'll be even more cautious, even more prudent. I also believe that it happens best when engineers are absolutely in charge of the how, but this is very infrequent. So today I'm a CTO. I work quite a lot with the product design, and I do believe that our point is to bring clarity about what impact we are trying to have. Not exactly what features we are trying to build, but what problems we are trying to solve. And when we push down what problem we are trying to solve and leave more freedom, but also more accountability to engineers, it means that the actual approach becomes their idea. They're like, oh, we have an idea. Maybe we can solve this problem this way. And if they reach an obstacle, if they face an obstacle, then they can change the idea because it was their ideas. So they feel like they own the path to solving the problem. While what happens most of the time is that we push down the solution. Like we start with, we are trying to solve that problem, and then product works, like they do user interviews, and then design like brings their value, and like, okay, this is one way to solve the problem. So we reduce the scope until we have like a pretty good idea and visualization and design of the solution, not of the problem, the solution. And this is what gets handed over to engineers to build, not to solve, to build. But then they have no freedom anymore because they also need to please, and it's more complex than just pleasing, but are trying to build someone else's ideas, which means they have zero freedom, which means they are very uncomfortable, like challenging it and changing anything, because the design was done, and there was already like a lot of discussion about why exactly it was supposed to be this way. And this, I think this is also what participates into the overcautiousness of building the stuff that someone else has designed. And it could be the same person with different hat, by the way. But I think part of the problem is when engineers are used to build and not to solve, we are definitely going in that direction of failing too late and not enough.
Yeah, of course. This feeling of, if this fails, it shouldn't be my fault, right?
Yes, exactly. I can't recall how many times I still see on Slack, oh, there's a bug, like something much released 6 months ago. Oh, there's a bug, it doesn't work. Oh yeah, but it was asked from us to do it this way. It was asked. People use passive voice, like it's which is still better than Mr. X asked me to do it this way. This is even worse, but still, like they need to be innocent, and it's correct, right? They've been asked to build it. They haven't been asked really to solve the problem, because the system was in place and there was discovery, and supposedly all the aspects of the problem have been considered already, so they just need to build it. But I think it doesn't work, because they will need to build it and run it and fix it, and this is invisible, and this is a lot of work.
Yeah, and evolve it. And it feels like here we have a disconnect in the sense that you're operating, we're both in startups, but you're operating at a scale that's higher than mine, like bigger than mine. And so you have all these things, you start having the problems of, we don't want to fail as engineers because we've been told what to do. And so we don't want our part to be the problem, right? Whereas at my company, at my setup, we are small enough that we don't get told what to do as precisely as for us to be able to hide behind it, right?
Yes, but I think even when I was working like almost alone, or just with, like, I used to be a backend engineer mostly, so I worked very closely with the front end. There was the two of us working on a project in my like previous company, and there was typically one customer. So it was a much smaller scale, but still the problem was the same. The customer came with his ideas, like, okay, I want this and this and that, and we sort of knew that part of our job was to challenge, because this is also how you bring expertise, by challenging. But still, sometimes we had customers like having a very specific idea of what they wanted to build, and it felt like they were paying us to build it, not to challenge them, not to solve the problem. So even at smaller scale, it happens that your job feels like building it and not solving the problem.
I see what you mean. I come back to the example I was sharing. We are changing our approach to something, and that's what we're trying to do as a working skeleton. And the idea is to introduce points of failure on purpose, or things we have not built on purpose, so we get like, we know we are failing in advance. And that, is that a failure or not? It's debatable, because if you know it, Are you really
There's something.
failing?
It feels like something like pre-mortem. It's something I like. I don't do it enough, but I love the idea. As like, imagine the stuff you're going into where in 6 months and it failed like dramatically. It's in every newspaper. Like, this is how dramatic it is. Now, can you imagine what is the content of the article in the newspaper? Why exactly? No, they know and they have analyzed it. And why did it fail? I love the idea. I don't do that much, but I love the idea of thinking this way because it removes the fear a little bit. Like, it could fail a thousand different ways, but when you have to write the article about what exactly failed, what specifically failed, then it reduces the fear and you can focus on the actual problems.
I feel, and I'm going to change a bit the subject, but I feel like there is an undercurrent permeating the conversation or something that keeps popping in my head when we talk. And I feel like there are different places to fail and they each have their rhythm and they each have their consequences. You mentioned at the beginning, you do TDD because you like to fail the code fast. Like, there are failures that are immediate.
It doesn't even feel like failing, right? Like
Yeah.
a red test doesn't even feel like a failure.
Yeah, exactly. But technically it is, right? Or you could consider it is, but again, when you're planning to fail, is the failure a failure or is the failure a success? Who knows, right? And there is that area. There is the area of system design, which is really code based in the sense that is it the engineering failures, the system we built was not set up for XYZ or cannot change enough, and those are some types of failures. And there is the product failures. Did we build the right idea? Did we fail enough, fast enough? And there is the how we work failures, right? And I feel like each of those has their own rhythm. Some of them are complicated to fail fast.
Yeah, absolutely. Absolutely. Definitely agree. So, it's like the saying we have as software engineers, make it right, make it work, make it right, make it fast, in that order. And the first one, make it work. This is about correctness or accuracy if you're doing something which is like probabilistic. But those you can fail fast. Those you can aim at TDD and like how correct is your software is something you can definitely fail fast. And also when it is incorrect, it's obviously incorrect.
Yeah.
So even if it's an edge case, like nobody is arguing whether like this is incorrect or not. But if I understand your question right, like there's a second category and well, it's like less obvious. You cannot fail fast. You need to measure for like some amount of time. And also when it is failing, it's not entirely black and white. Like, is it failing because it doesn't meet enough of the success criteria? And this is also a big question. Like, if you aim, if you do a test, you aim for 70% and you're 65%. Did you fail? Well, if you aimed for, if you said like the success criteria is 70%, you didn't. Now, the thing is, when you go for an experiment, maybe your success criteria is currently at 60% of success, whatever, and then you're 62, it's a success. But then it changes phase. There's a new milestone, and now you need to reach 80%, which means you're actually failing today, even though you're still at 62%. So you're failing because it's not enough of a success. It's not enough of make it right. It's right-ish, but it's not enough right. And this is also probably, again, I don't know anything about Google, but this is what I would imagine about like very large companies. They have higher, I would imagine them having higher threshold of success and saying, okay, if it doesn't work with a million concurrent session, it's failing. Well, I don't have that criteria most of the time.
There is also something to be said about the circumstances changing. Something that was not a failure for 3 years can become a failure overnight because whatever, right? Like, you had your whole company set up on using a lot of gas and now there is a war. You don't have gas anymore. That was a mistake or a failure or whatever, right? Are there lessons to be learned from the environment causing you to fail at your ideas? Because right now we have been talking a lot about we make choices. Those choices reveal themselves to be a failure after X time. And so we can learn from them. But if it is I had a SaaS, and now because of AI, SaaS doesn't work anymore. Let's assume that's even close to true. Did I fail making a SaaS at the time? And can I learn something from that?
Okay, those are yes/no questions. So kind of complex to answer to. Can you learn? You can always learn. You will learn in success. You will learn in failure. I think we learn better in failure, by the way. So if your purpose is to learn, you should definitely fail because you will learn much better. What will you learn? That I don't know exactly. If you failed at like at a company, at a big stuff, you will definitely learn a lot, and that learning will also be accompanied by an emotional experience. So you will learn some rational ideas, hopefully, but you will also learn to avoid the emotional state of being hurt. And again, I do believe that the main reason why we are too cautious is an emotional reason. So maybe you will learn to not go solo for a venture, or you will learn that people are mean, or I don't know. You might learn a ton of stuff, and I would say that the biggest lesson will be emotional, and they will have an impact. So that was the second question, like, can you learn? The first question was, can it be avoided?
No, is it still a failure when it was the world changed?
It depends on your success criteria, but it can be a failure. I mean, it doesn't mean it's shameful. Maybe that's the problem. I don't know, or part of the problem. Maybe we are confusing failure and shame for some reason, especially for people who are perfectionists, or like, the drivers, the psychological driver, like the be strong and be perfect. I think these are very frequent in our teams. And typically, be strong is someone who needs to be above the melee, maybe, like comparing to other people. So it means that if you fail your venture while the people you look at are all succeeding, you will feel very bad. But it also very much depends who you look at. The perfectionist typically always measure themselves and evaluate themselves according to their ideas of perfection. So they are always measuring how far they are from perfection. So they could definitely consider that failing a venture would be far from the perfection of succeeding their venture, even though the reason for the failure, like not at all being in their control, it doesn't really matter. So they could still be experienced as failure, but it doesn't mean there's a problem with that.
I I agree with you with the failure does carry some feelings with it, right? Like being a failure is something that is perceived emotionally as being bad. And it drives into all that what you said a couple of minutes ago of, yeah, when it's red, I don't even see it as a failure, but that's because you don't feel bad about it, right? And it drives into this, maybe in order to fail sooner, what we should start seeing is failure not as failure, or redefining failure as success.
Yeah, this is exactly what we did with test, right? And this is also something that people who do not do TDD, BDD maybe get a hard time with, because if you write your test after the code, you're already expecting your code to be right. So a red test already feels harder than if you do TDD. And like, if you do TDD, your test is red. Obviously, you didn't even write anything. So I think it goes in, I think it goes in that direction. And definitely, like, the confusion of failure with shame, this is the best emotion I can come up with, definitely is a problem. We could use different words. There's two words that come to my mind. I know that it could be unsuccessful. It's already different from failing. It's just not a success. So I don't know if this would change things, but it could. And I'm also thinking about scientific papers and stuff like that. And very often the conclusion says, what we did was inconclusive. I like that idea. It's not we failed at. It's just like we could not conclude what we expected to conclude, neither positively or negatively, because there's not enough clues in either direction. there's no shame in that. And I know that actually when you talk to academic researchers, they don't feel good about inconclusive papers. It's like, we need to publish, we need to be, we have to be like a very strong conclusion at some point. So even if I say that inconclusive is better than failing, I know this is not how they feel about that. But I do believe that the word inconclusive conveys less negative emotion than failure.
I agree with unsuccessful because that's a state. Inconclusive feels worse to me in the sense that if I was unsuccessful, I learned something. If it was inconclusive, I don't know. Maybe
But
I learned.
inconclusive can only be used when you're intended to have a conclusion, right? So it only works for experiments, like intelligent
Yeah,
experiments.
but it implies it's neither good nor bad. It's 5 people use it. Is that enough? I don't know, maybe. Is that idea a good idea? Like, if no one uses it, I know that idea is a bad idea or not a marketable idea, at least. If everyone uses it, great. If it's inconclusive, I don't know. Is it? I don't know. You know what I
But
mean?
isn't it the correct statement though? Like you release something, you were aiming for, I don't know, 100 users adoption, and you got 85. Is it failure? I mean, failure is, at least it's simple to understand. It's a simple story. We are craving for good stories, and good stories usually are simple stories. But is it really a failure?
No, yeah, I get you. Like, if you were aiming for 100 and you get between 80 and 120, it's inconclusive, sure. But if you get 20, inconclusive is not the right word,
I think
right?
that would be a failure. I mean, depending on the circumstances.
Yeah.
Um, but again, we are talking again about product, and I think the audience is mostly about engineers. So the question is more like, how do you know if your code is failing? Again, not about being incorrect. Incorrect is obvious. Is your design, like you decided to go for an event-based system, right? A lot of work, but you do believe that it's really relevant for whatever you're doing at. Was this a success? How do you know?
Vibes. Like, at the end of the day, are you fighting the code more than you were helped by the code or not? And that's really hard to measure.
Yeah, but then how do you decide whether you're gonna go for event-based the next time, or maybe like not, like microservices, NoSQL? I mean, our industry is very fashion oriented. So vibes is a very dangerous measuring stick.
Yes, but, and I think that's another episode at another time, I believe that vibes is most of our measurement.
I believe so, but this is why fear of failure takes so much weight in the way we decide.
Of course. And after almost an hour of discussion, we've gone full circle. So I think it's a great place to stop. We are failing too late. There are avenues we can explore to fail sooner and to recognize that we are afraid of failing, and we should not be afraid of failing, and we should not associate negative feelings to failure, but failure still exists.
Yeah, I think what a good takeaway I will personally get from this discussion is how things like TDD redefines what is a failure and removes the shame. I think this is a good example. Maybe there are like other areas where we can actually remove the bad feeling from failure in a way or another. And there was also, like, as I told you before, I did a little bit of prep to clarify my ideas for this episode. And there was one thing I wanted to share, so I'm sharing it now. The most efficient hospitals in the world have the highest amount of reported issues. I think it's a very interesting statistics because they are still the most efficient ways, so they likely do not have more issues than other hospitals. I do believe they report it more. And I do believe they report it more because it's safer, or for some reason, it, reporting it is better incentivized. And I'm wondering how we can learn something from them and apply it in our industry.
Yeah, it's interesting. Probably the reporting drives the effectiveness, which drives the reporting, which drives the effectiveness, and it's probably a virtuous circle once you start getting into that mindset of an issue is not a failure, right?
Yes.
Cool. Thank you very much, Philippe. It was a really interesting discussion, as expected, as usual. Very nice to have you on the podcast.
Thank you, Pablo.